We're going to do the polynomial division worksheet. This is a review, except there are some new things that you may not have seen in the past. So I want to start with number 2. Can I use synthetic division on number 2? Yes, because the bottom has one factor and the root is a whole number. Can I use synthetic division on number 1? You can, but your answer will need to be adapted in the end because the root of the denominator is -5/2. It's a fraction. So it will work, but it's a little problematic. So for number 2, what is the root that goes in the corner? 5. And then we list out the coefficients. 1, -4, -8, 20, and -25. And we drop down the first one. And then we just multiply, add until we get to the end. 5 times 1 is 5. -4 plus 5 is 1. 5 times 1 is 5. -8 plus 5 is -3. 5 times -3 is -15, which gives me 5. And that gives me 25. And I get a remainder of 0. Okay. And just for review, what does that tell me about x equals 5? Well, it goes in evenly. What does that mean? It's one of the roots of the numerator. So the numerator is some combination of 4 roots. Or sorry, of 4 factors. So the denominator was x minus 5, which means one of the other factors is x minus 5, and they just cancel. And it also means that this graph here, the original graph, hit the x-axis at 5. I don't know where the other 3 places it hits, and it might not hit anywhere else, but we know that one of them is 5. All right, what is the resulting equation of the division? Well, this was an x to the 4th, and I divided it by an x, so I now get 1x to the 3rd plus 1x squared minus 3x plus 5. And that is the polynomial made up of the remaining factors when I removed the x minus 5. Okay. Let's do number 1. So I'm not going to use synthetic division. I put 2x and a 5 in the box. I don't know how many columns there will be until I get to the end. And I put the 4x to the 4th in there. Pull out a 2x, and I get 2x. And then 2x times 5 is 10x. And I'm not finished with the numerator, so I add a column. 10x and that blank spot need to add up to be 4x to the 3rd. Sorry. 10x to the 3rd, and what make 4x to the 3rd? -6x to the 3rd. And if you want to do long division, go for it. I think it's terrible. Pull out 2x. We get -3x squared. Multiply that by 5. -15x squared. I need to add a column. -15 and the blank spot need to add up to be 10. Nope, 1. Sorry. So 16x squared. Pull out a 2x. Times that by 5. Add a column. 40 and the blank spot need to add up to be -10x. So I need to subtract 50x, take out a 2x, and I get -25. -25 times 5 is -125. Do I need to add a column? No, because -25 is the constant. Okay. What if I did? What if I put a 12, I had to put a 12 here? How do I handle a remainder? Other than giving up, you write plus, and then you write the remainder divided by the original divisor, 2x plus 5. But in this case, there was no remainder, so we're not going to worry about it. Are we okay with simple box division and synthetic? Yes. Yep, that's the next one we're going to do. Okay. On number 3, can I do synthetic division? Yes, because the root of the denominator is a whole number. It's an integer. So I put -4 in the box. What are my coefficients? 2, 0. There is no x squared term. So we have to put a placeholder where it would be, and then -4, and then 112. So we drop the 2. -4 times 2 is -8. -4 times -8 is 32. That's 28. And then -4 times 28, what do you know, is -112. We're just missing the squared. Okay. So the original equation was an x to the third. So my resulting equation is 2x squared minus 8x plus 28. Okay. Okay, we'll show you. Let's do number 4 using the box. So x and 3. We put in the x to the third, pull out an x, we get x squared. X squared times 3 is 3x squared. Now here's where it gets a little tricky. These two need to add up to be 0. There is no x squared term in the numerator. So it's just -3x squared, which makes this -3x, which makes this 9x. Add a column. These two need to add up to be 0 because there's no x term. So, oh, that's a -9. So 9x plus 9, 27, and I'm done. Okay, everybody good with that? Look at number 7. Can I do synthetic division on number 7? No. The bottom is a quadratic, which means there are 2 factors, and those factors are not even very nice numbers. Are there 2 numbers that multiply to be -2 and add to be 4? No, so there's some nasty square root number that we don't want to mess with. So because it's an x squared, I cannot do synthetic division. And the denominator has 3 terms, so my box will have 3 rows. And this is where long division really gets hard. Well, this one's not bad. The next one's worse. And again, I don't know how many columns there will be. So I drop down the 2x to the 4th. Pull out an x squared, and I get 2x squared. 2x squared times 4x is 8x to the 3rd, and 2x squared times -2 is -4x squared. That's the very first term. Yeah, that helps. Okay, add a column. These need to add up to be 8x to the 3rd. Oh, that's nice. So what should I put in its place? 0. And I recommend that you do 0x to the 3rd, just so you can keep everything organized. What happens when you pull an x squared out of 0x to the third? You get 0x. Now, do I need that? No, but I'm going to write it down so that I don't make a mistake. And 0x times 4x is 0x squared, and 0x times negative 2 is 0x. So notice, if you have 1 0 in a column, that whole column is going to be made up of zeros. But we write them so that everything lines up the way we want it to. Did I finish the numerator? No. So I add a column, and this is a little bit tricky because there are now 3 boxes. So negative 4 plus 0 plus the empty space is supposed to add up to be negative 5. So negative 1x squared, or just negative x squared. Pull out an x squared, I get minus 1, which gives me negative 4x, which gives me 2. Okay, did I finish? Okay, and this is a little bit tricky. Do these add up to the correct thing? Yes. Does this add up to the correct thing? Yes. So we're done. Okay, number 8. No, because 2 is part of the equation. So the negative 4 and the 2 are there. They matched, so we're done. There's no remainder. Okay, how are we going to handle number 8? How many rows does number 8 have? 3. Okay, but I only see 2. What's the third row? The middle row is supposed to be 0x. Can I do synthetic division? No. So 3x squared, 0x, and negative 2. Now, do I need the 0x? No, but if you don't, your diagonals won't line up. If you put the 0x, then all of your diagonals will be like terms. If you don't, then your diagonals won't be diagonals. They'll kind of jump around. Good point. So I have a 0 in the middle, so my entire middle row will be full of zeros. But it'll be like 0x squared, 0x, and like that. Okay. I bring down 3x to the 4th, pull out a 3x squared, x squared, 0x to the 3rd, negative 2x squared. Add a column. These two need to add up to be, not 4x squared, 0x to the 3rd. The numerator is missing a place. So 0x to the 3rd, and then I pull out a 3x squared and I get 0x, which is 0x squared, and then negative 2x. Now, oh, that's a 0. Sorry. I don't know math. Okay. Now, imagine if I didn't put that. So pretend this middle column isn't here. What would you match the 2x squared up to? It would be the top box of the next row, which is a little bit hard to see. So you need to put all those zeros in there so that you can do this. So negative 2 and 0 and the blank need to add up to be 4. So how many x squareds do I need? 6. Pull out a 3x, and then this is 0x, and then this is negative 4. Okay. This is going to hurt your head for a second. Okay. Do these add up to the correct number? No. What do they need to add up to? Negative 13. So I add a column, and I put a negative 13x. Can I take out an x squared? No. All right, and then the next one is negative 4. Does it add up? Do these add up to negative 4? Yes, so this remainder is a 0. So my remainder is plus negative 13x over x squared minus 2. And let me stop before I change things. 3x squared. Thank you. Okay. Well, what if this would have been a 3? And these need to add up to be negative 4. So what would go there? A negative 7. And then we would do this. So we would have a remainder that's a linear function. That's weird. We've never had a two-part remainder before. But when you divide by an x squared, your remainder can be an x plus something equation. If you divide by x to the third, your remainder could be quadratic. Your remainder could be x squared minus 6 plus 2. So just like in division with whole numbers, your remainder is smaller than your divisor, right? If you divide by 6, what's the biggest remainder you can get? So if I divide a number by 6, what's the biggest remainder I could get? 5. Why not 6? Because if your remainder is 6, it's actually one more number and your remainder would be 0. Okay? So when your divisor is an x squared, your remainder could be an x. If you divide by x to the fourth, your remainder could be x to the third, x squared, x, and then like 3. Which is a little bit weird, but it can happen. Well, that's everything you need to know. Are you ready to try those? Do you want to see one more? One more? Okay, we can do 10. All right. How many rows on 10? 3. X squared, 0x, and negative 3. Okay. 3x to the fourth. Pull out an x squared. 0x to the third. Negative 9x squared. Add a column. Those need to add up to be 0. Okay. Oh, thank you. These need to add up to be negative 25. Oops, that's a 16. So 0x, and I believe 48. And then those need to add up to be 0. They already do. And those two need to add up to be 48, and it already does. So the answer is just 3x squared minus 16. That one wasn't too bad. Yeah, it's a 16. Okay, look at number 14. How many rows will number 14 have? 4. X to the third, 0x squared, 0x, and 1. And the same thing with 15. You'll just have a 0x row. All right, your answers are right there. So you need to show your work when you're done with it, or next time when you come back, you need to put it in the A4 box over there. All right? Who needed this? Yeah? Sure, that's fine.